Hello and welcome to Sleepy Science Story. This is your time to slow down, to let the noise of the day soften into a gentle hush, and to drift somewhere a little farther away. Tonight, we're going to wander into the most invisible mystery of the cosmos, something that makes up almost everything, and yet can't be seen, touched, or heard. Dark matter. It's the quiet scaffolding of the universe, holding galaxies together like invisible silk threads spun through eternity. I do hope this video isn't so interesting it keeps you awake, but if it does, at least your dreams will be filled with starlight and the soft hum of space itself. Before we begin our sleepy science wandering, I'd love it if you gently tap the like button. If you enjoy these calm cosmic journeys, feel free to subscribe to Sleepy Science Story. It helps more curious night minds find their way here. Now, let's dim the lights of the mind and let the universe unfold like a slow, silvery tide. Imagine, for a moment, that you are drifting high above the Milky Way. The galaxy spreads out beneath you like a slow whirlpool of light, arms of stars spiraling gracefully around a quiet center. From this vantage point, you might expect to see chaos stars flying apart, spinning loose, scattering into the dark. But they do not. They move in harmony, bound by something unseen, something that keeps them tethered together even as they twirl across millions of light years. This invisible glue is what scientists call dark matter, and though we cannot see it, we can feel its pull in every orbit, in every curve of light, in every cosmic breath. Astronomers first began to notice this strange steadiness when they measured the speeds of stars circling their galactic cores. According to Newton's and Einstein's laws, the farther a star is from the center, the slower it should move, just as planets farther from the sun take longer to complete their orbits. Yet the stars at the edges of galaxies were racing along almost as fast as those near the center. It was as though some invisible hand was holding them in place, balancing their motion with unseen weight. That invisible hand, we now believe, is dark matter, quietly shaping the stars from behind the curtain of visibility. If we could somehow turn on special glasses that let us see dark matter, the night sky would look astonishingly different. The Milky Way would appear not as a delicate spiral but as a glowing cloud wrapped in a vast, spherical halo, hundreds of thousands of light years wider than the disk of visible stars. Each galaxy would be revealed as a jewel set within an invisible cocoon, drifting through a cosmos laced with invisible threads. These halos do not shine or glow or reflect. They are made of particles that ignore light entirely, passing through the luminous universe like ghosts through mist. There is a peaceful strangeness to this idea that almost all the matter in existence hides from our eyes. Everything we can see, from the smallest dust mote floating in a sunbeam to the brightest supernova lighting up a galaxy, makes up less than 5% of the universe. The rest lies in shadow, yet without that shadow, there would be no shape, no stability, no stars to whisper their stories through the dark. Dark matter is the quiet architect of everything that glimmers. It is humbling, really, to think that our understanding of the cosmos relies so heavily on what we cannot detect directly. Scientists map dark matter not by its light but by its gravity, watching how it bends and shapes the paths of galaxies and the arcs of ancient starlight. In this way, we glimpse the unseen, tracing patterns through the void, as though reading the ripples left on the surface of a deep, invisible ocean. As you listen now, perhaps your thoughts begin to drift too, like starlight bending around something vast and unseen. The galaxy turns slowly beneath you, serene and sure, held together by threads of mystery that neither glow nor fade. There is a comfort in knowing that even the invisible can be steadfast, that the universe itself leans gently on something it cannot see. In that quiet, the stars keep their rhythm, and you, too, can rest in the calm gravity of the unknown. There was a time when scientists believed they understood the architecture of the universe quite well. They could measure stars, chart galaxies, and predict their motions with neat precision. The cosmos, though vast and distant, seemed logical and obedient to the laws of gravity. But as telescopes improved and measurements became more precise, something quiet but stubborn began to whisper through the data. The numbers did not align. The stars on the edges of galaxies were spinning too quickly, and clusters of galaxies were behaving as though they carried more mass than their glowing contents suggested. Somewhere between the starlight and the equations, something was missing. It began as a curiosity, a small mismatch that could have been blamed on error or assumption. Yet, as the observations multiplied, the discrepancy deepened. The galaxies refused to behave like the visible matter predicted. Their stars moved as if an invisible weight surrounded them, as though space itself were filled with a silent companion substance that anchored everything in place. Astronomers could not see it, could not touch it, could not measure it directly, but they could see what it did. It was as though the universe had written its secrets in the margins, and we were only just learning how to read between the lines. Imagine being an astronomer in those early decades, sitting under a dim red light, examining spectral lines printed from a telescope thousands of miles away. The galaxies would have appeared serene, quiet, and distant, yet their motion told a story of something immense and hidden. It must have been both thrilling and unsettling. To realize that the bright, brilliant universe of stars and gas was only the surface of a much deeper reality is to stand at the edge of a revelation. Like a child discovering that the ocean continues far beyond where the sunlight fades, humanity was realizing that what we see is just a shimmer atop something infinitely darker and grander. This missing piece came to be called dark matter, though the name does little justice to its mystery. It is not dark in color or temperament. Rather, it does not interact with light at all. It neither absorbs, nor emits, nor reflects. To our eyes, it is pure absence, and yet it is there, woven through every galaxy, binding stars into spirals and clusters into cosmic webs. Without it, galaxies would simply fly apart, their delicate order undone by their own motion. There is something soothing about this balance, something almost poetic. The universe seems to know how to hold itself together, even through the quiet forces we cannot sense. Dark matter became the missing piece that completed the cosmic puzzle. It explained the unexplainable and filled the gaps between stars with silent purpose. Every orbit, every glimmer, every gravitational tug owes part of its harmony to this unseen mass. The idea that most of the universe is made of something invisible can feel strange, even lonely, but perhaps it is comforting too. It reminds us that there is always more than what we can perceive. We live surrounded by the invisible, supported by it, gently carried within its pull. Even now, as we lie beneath the night sky, the galaxies drift within their invisible halos, moving through the cosmos as if guided by unseen hands. The missing piece, the quiet weight of existence, has always been there, shaping everything while revealing nothing. And maybe that is the most peaceful truth of all, that the universe holds its secrets softly, waiting for us to rest long enough to listen. Gravity has always been the quiet voice of the universe, the steady whisper that keeps everything in place. It is not loud or bright like light, nor fierce like radiation. It is gentle and patient, pulling slowly across the eons, shaping everything from the curve of your hand to the sweep of entire galaxies. When we look into the night sky, we do not see gravity itself, but we see what it has made. The arcs of stars, the spirals of galaxies, the way light bends around invisible corners. It is through these subtle gestures that we come to know dark matter, the silent companion that never reveals its form but always leaves its shadow in the language of gravity. Imagine floating far beyond the Milky Way, where the familiar stars have faded into a thin shimmer. From here, the galaxy appears as a luminous disk, turning slowly in a vast sea of darkness. The outer stars move faster than they should, as if held by invisible threads. There are no beams, no ropes, no visible hands guiding them. Only gravity, responding to something hidden, something that weighs without shining. It is through this pull that dark matter speaks, its presence felt but never seen. Scientists call this invisible influence a gravitational effect, but perhaps it is better to think of it as a kind of echo. The universe hums with the vibration of unseen mass, and light, being the most delicate traveler, bends and twists in response. When distant starlight passes through a field of dark matter, it curves ever so slightly, like a ribbon drifting through water. To us, this bending is a message, a sign that something silent and heavy has shaped the space it passes through. This is known as gravitational lensing, and it allows us to trace the outline of the invisible by the way it plays with light. The thought is almost tender, that light, the swiftest and purest thing in existence, still cannot escape the touch of gravity. Even photons, racing at the fastest possible speed, bow slightly when passing near something massive. In this way, dark matter paints invisible art across the cosmos, using gravity as its brush and light as its medium. Galaxies distort and elongate when viewed through these lenses, their shapes stretched into faint arcs, like reflections rippling across water. This is how we learn about dark matter, not by capturing it in a jar or detecting it directly, but by watching how it affects the things we can see. It is a patient kind of science, one that listens more than it demands. Each faint distortion, each small deviation in motion tells us a little more about the unseen weight that holds the universe together. And perhaps there is comfort in this mystery. Just as you can feel the warmth of sunlight without seeing the wind that moves the leaves, so too can the universe be understood through its quiet interactions. Dark matter reminds us that not everything that matters needs to glow or make a sound. Some forces exist only in the way they hold, the way they steady, the way they endure. As you let that thought settle, imagine yourself drifting in that deep cosmic darkness. Around you, the galaxies spin like slow lanterns on a distant tide. Between them, gravity flows in silence, drawing unseen shapes that hold the stars in their dance. The shadows of gravity stretch far beyond where light can reach, and in that vast quiet, the cosmos breathes softly, eternal and unseen. In the early 1930s, long before the word dark matter found its way into textbooks or documentaries, there was a man named Fritz Zwicky who looked at the universe and saw something no one else had dared to imagine. He was not a quiet man, and he was not known for his gentleness, but in his own eccentric way, he stumbled upon one of the most silent truths the cosmos had ever held. He worked at Caltech, in the clear, dry air of California, where the night sky seemed close enough to touch. Through his telescope, he studied clusters of galaxies, hundreds of shimmering islands of stars floating together through the deep. But what caught his attention was not the beauty of what he saw, it was the math that refused to make sense. Zwicky noticed that the galaxies within these clusters were moving too fast. According to the visible amount of matter, the stars, the gas, the glowing light, there simply wasn't enough gravity to hold them together. They should have drifted apart long ago, scattering like handfuls of glitter thrown into the wind. Yet there they were, bound, spinning in delicate harmony. He called this missing mass Dunkelmaterie, which in German means dark matter. Few believed him at the time. His idea was too strange, too ahead of its moment. Scientists preferred to think that perhaps the measurements were wrong or that some hidden force was at play. But the seed had been planted. There is something poetic about the way great discoveries often begin not with a flash of brilliance, but with quiet confusion, Zwicky had seen the first hint of the invisible framework of the universe. He could not name its nature or describe its particles, but he had sensed its presence like a distant echo. Decades later, other astronomers, most famously Vera Rubin, would confirm what Zwicky had suspected, measuring the same impossible rotations in galaxies across the sky. What had once been dismissed as eccentricity became one of the pillars of modern cosmology. If we could have asked Zwicky what he felt on those nights, staring through the telescope, he might have spoken of frustration. He was known for his fiery temper, but perhaps, deep inside, there was also awe. To recognize that most of the universe is made of something we cannot see is to feel both very small and strangely connected. Zwicky looked into the dark and saw not emptiness, but the faint outline of structure. Even now, his discovery carries a kind of quiet intimacy. When you look at the night sky, you are not only seeing the stars that shine, but also the gravity of the unseen that holds them together. Every glowing cluster, every spiral of starlight, still obeys the laws Zwicky helped reveal. His name may not be whispered often, but his insight ripples through the cosmos every moment, in every orbit and every beam of light that bends under the weight of the invisible. As you lie back now and picture him, alone in the observatory, the hum of the equipment soft and steady, imagine the cool air drifting in from the desert and the faint sound of night insects. Beyond the mountains, galaxies are gliding through space, bound by threads that no eye can see. Somewhere, Fritz Zwicky is still watching them, still muttering calculations into the quiet, still listening for the heartbeat of the invisible. And in that steady cosmic rhythm, you can almost hear the whisper of discovery, the soft sound of the universe revealing itself, one impossible truth at a time. Every galaxy in the universe is a kind of miracle, but some are so peculiar that they seem to defy the very laws that hold them together. Imagine a vast spiral of stars, beautiful and delicate, spinning gracefully through space like a slow ballet. Each of its stars moves in perfect rhythm, held by a balance between motion and gravity. Now imagine that same galaxy spinning too quickly, so fast that its edges should tear away, flinging stars out into the cosmic dark. And yet, somehow, it stays whole. This is one of the great puzzles that led astronomers to the realization that something invisible, something weighty and unseen, must be holding the galaxy together. It is almost haunting to think of galaxies like this. They whirl through the void, shimmering like celestial pinwheels, their light bright enough to cross millions of years. Every star within them should be racing toward oblivion, yet they remain in place, as if caught in a quiet cosmic embrace. The secret behind that calm lies in dark matter, the invisible mass that surrounds each galaxy like a soft halo. It does not glow or shine or burn, but it keeps the stars from drifting away, binding them in a gentle but unbreakable hold. When scientists first noticed this strange behavior, it seemed impossible. They measured, recalculated, and checked again. The outer stars were moving far faster than any known law of gravity should allow. The visible matter, stars, gas, and dust, was not enough to explain their speed. There had to be more. Something unseen was adding its weight, keeping the galaxies intact. Over time, as more and more galaxies revealed the same impossible pattern, the truth became harder to ignore. The universe was not made only of what we could see. Dark matter became the answer to the question no one had wanted to ask. It explained why galaxies did not fly apart, why clusters of galaxies held together, why the universe itself had structure. It became the silent stage on which all cosmic drama unfolds. Without it, the night sky would not be a map of shining constellations, but a scattering of lonely stars, each one adrift. There is something deeply comforting about this idea, that even the most chaotic systems are held by invisible order. that the universe, for all its mystery, has a kind of patience built into it. Dark matter does not need to announce itself or demand recognition. It simply holds, quietly, endlessly, like the gravity of a promise. When you look up at the Milky Way on a clear night, remember that much of what you see should not even be there. The spiral arms, the glowing bands, the clusters of light are all suspended in place by something that refuses to be seen. Every star you trace with your eyes is part of a dance choreographed by an invisible force. And perhaps that is what makes it so beautiful. The galaxies that should not exist, that should have unraveled long ago, continue their slow rotations in the dark, serenely unaware of the chaos they defy. They drift through time as if held by faith alone, glowing softly against the silence. Somewhere out there, in a spiral arm or a distant core, a star flickers in perfect rhythm with the unseen weight that holds it, just as your breath finds its rhythm now. In the great stillness between what is visible and what is not, the universe reminds us that even the impossible can endure quietly, forever, without ever needing to be seen. If you could float somewhere between galaxies, far away from any single source of light, you might think the universe there would be utterly empty. Yet even in that deep stillness, light finds ways to bend and twist, as if brushed by unseen hands. When astronomers peer through their telescopes at distant galaxies, they sometimes find that the light from those faraway worlds does not travel straight. Instead, it warps and curves before reaching us, as though space itself has been molded by something invisible. That invisible sculptor is dark matter, shaping the path of light with its gravity and revealing itself only through the distortions it leaves behind. This phenomenon is called gravitational lensing, and it is one of the most delicate tricks the universe performs. Imagine holding a glass marble up to your eye and looking at the stars through it. The light bends slightly, spreading into soft arcs and rings. That is what happens when light from distant galaxies passes through regions filled with dark matter. The dark matter bends the fabric of space so subtly that the light must follow the curve, arriving at Earth with its journey quietly rewritten. What we see through our telescopes are faintly stretched shapes, shimmering arcs of light that tell us something unseen lies in their path. For scientists, these cosmic mirages are maps. By studying how light distorts, they can trace the hidden presence of dark matter, painting invisible landscapes across the cosmos. In some deep images of the sky, such as those taken by the Hubble Space Telescope, faint galaxies appear to circle around empty patches of space, forming ghostly halos of light. The emptiness is not empty at all, it is filled with dark matter, bending and guiding the light like a lens made of gravity. There is a dreamlike quality to this, as though the universe were whispering secrets through illusions. We see what light allows us to see, yet behind that radiance lies something older and quieter. The bending of light is gentle, like the way wind shapes ripples on the surface of a pond. Through these ripples, we glimpse the depth of the unseen. Dark matter, though invisible, leaves its mark as a soft fingerprint upon starlight. Some of the most profound images in astronomy come from these distortions. Rings of light, known as Einstein rings, form when a distant galaxy lines up perfectly behind a massive cluster of dark matter. The light bends evenly in all directions, creating a glowing circle, as if the universe were drawing halos around its mysteries. To look at one is to witness geometry turned to poetry. The light from galaxies billions of years old has traveled across space, brushing past dark matter along the way, and what reaches us is a gentle echo of that encounter. Even though these distortions are tiny and fleeting, they remind us that space is not a static backdrop but something alive and responsive. It bends, stretches, and curves, dancing in harmony with gravity. The dark matter that causes these illusions does not announce itself with noise or color. It moves in silence, shaping the cosmos in the way a sculptor's hand shapes clay, unseen but essential. As you rest, imagine that same starlight passing above you, invisible beams curving softly around unseen weights. Somewhere in the quiet between galaxies, light bends and continues its long journey, carrying the faint touch of dark matter. It will travel for millions of years before it ever reaches another eye, another dreamer wondering what lies beyond. Perhaps it is comforting to think that even light, swift and untouchable, still listens to gravity's gentle call, and in that patient obedience, the universe reveals its most tender secrets. If the universe were a great quilt, dark matter would be the invisible thread that holds every patch together. It is not something we can see, and yet without it, the entire fabric would unravel. Galaxies would drift apart, clusters would dissolve, and the cosmos itself would lose its delicate structure. Scientists have often tried to picture what dark matter truly looks like, but perhaps the better question is not how it appears, but what pattern it weaves. Everywhere we look, the influence of dark matter is there, subtle but absolute, a kind of cosmic embroidery that ties the visible universe into its shape. Imagine looking at a tapestry from afar. You see the colors, the patterns, the shapes that tell a story. But if you walk close enough, you begin to notice the tiny stitches that bind everything together. Those stitches are almost invisible, yet they are what make the whole picture possible. That is what dark matter does on the grandest scale imaginable. The galaxies, the stars, even the glowing gas that fills the spaces between them, all of it is threaded through by the gravity of dark matter. It does not shine, it does not burn, but it holds everything gently in its quiet strength. Scientists have tried to map this hidden fabric, using the way galaxies move and the way light bends to trace its outlines. What they find is astonishing. The universe is not evenly filled with matter, but arranged in an intricate web, with filaments of dark matter stretching across vast distances. Where these threads intersect, galaxies cluster together, drawn into knots of gravity. Between these filaments lie enormous empty regions, the cosmic voids, where almost nothing exists. It is as though the universe itself has a skeleton, an invisible framework upon which all its beauty rests. To think of dark matter this way is to imagine the cosmos as something alive, something stitched together with invisible care. Each galaxy sits nestled within its own halo of dark matter, like a pearl in a thin cocoon. These halos connect to others across unimaginable expanses, forming bridges of gravity that span billions of light years. The light we see from galaxies travels along these bridges, following the paths shaped by the unseen. It is through this quiet scaffolding that the universe has built itself, layer upon layer, for nearly 14 billion years. When you close your eyes and picture it, you might see it as a kind of glowing lattice, though in truth, it emits no light at all. You might imagine yourself drifting through that structure, weightless, surrounded by faint glimmers of galaxies clinging to their dark anchors. There is no sound there, no wind, no motion you could feel, and yet there is a sense of deep coherence, as though the universe itself is breathing slowly, held together by the invisible threads of its own making. Dark matter is the fabric beneath the fabric, the quiet foundation of creation. It is what allows structure to exist at all, transforming chaos into form without ever being seen. As you drift further into rest, you might think of it as a gentle reminder that not all strength needs to be visible, and that the most enduring bonds are often the ones that work in silence. The galaxies continue their slow waltz, the threads remain taut, and somewhere in the soft darkness between the stars, the universe keeps its quiet weave intact, never breaking, never fading, always holding. Our Milky Way floats in space like a calm spiral of light, its stars and gas drifting together through the silent dark. Yet the glowing band we see in the night sky is only a small fraction of what truly makes up our galaxy. Surrounding it, unseen and immense, is a vast halo of dark matter. It stretches far beyond the most distant stars, wrapping the Milky Way in an invisible cocoon of gravity. It has no color, no temperature that we can measure, and no edges that we can define. And yet, without this halo, the galaxy itself could not exist in the steady, graceful shape we know. If you were to leave Earth and travel upward, past the solar system and into the quiet regions beyond the outer planets, you would still be moving within the influence of dark matter. It extends hundreds of thousands of light years in all directions, forming a sphere of weight and silence. The stars at the edge of the Milky Way, the ones we can barely detect, still orbit within its pull. Even beyond them, where the darkness seems complete, this invisible mass continues. It is as though our galaxy rests inside a bubble of unseen gravity, suspended in an ocean of the same. Astronomers have learned of this halo not through direct observation, but through the behavior of the stars it holds. The outermost stars move too quickly to be bound by visible matter alone. Their motion reveals the presence of a great envelope of mass surrounding them, a presence that makes the galaxy stable and whole. In this way, the Milky Way is not just a disk of stars, it is a living structure wrapped in quiet strength. Some scientists like to describe this halo as cold, not because of temperature but because of its calmness. The particles that make up dark matter move slowly compared to the speed of light, and so they cluster, forming these vast halos around galaxies. The term cold fits them in another way too. They do not glow or spark or radiate. They simply exist, steady and patient, doing their work in silence. If we could somehow see the dark matter halo, it might look like a faint cloud glowing around the Milky Way, softly pulsing with density, stretching far into the unseen. But even this image would be only an echo of the truth, because dark matter does not interact with light in any way. It passes through everything, even through us, without leaving a trace we can feel. It is there all the same, shaping every motion and holding every orbit in place. To think of the Milky Way in this way is to realize that we are not living on the edge of something solid, but floating within something vast and unseen. Every atom, every beam of light from our stars, moves within the embrace of this hidden halo. We are wrapped in it like travelers inside a sleeping cloud, carried along through space by its gravity. As you picture it now, perhaps imagine drifting beyond the stars, looking back at the glowing spiral of our galaxy. Around it, though invisible, lies that gentle sphere of darkness, quiet and immense. It holds every orbit in balance, every star in its path, every cluster in its place. It has no boundaries we can touch, no beginning or end that we can name. It is a silent guardian, a patient companion to everything that shines. The next time you look up at the night sky, remember that what you see is only a whisper of what holds us all. Beneath the shimmer of light lies a deeper stillness, and in that stillness, the galaxy dreams on, safely cradled in the cold, unseen arms of its halo. When astronomers look deep into the universe, past the soft shimmer of individual galaxies, they see a pattern emerge. It is not random, not scattered like confetti across endless space. Instead, the galaxies form long, delicate filaments, weaving together into an immense and ancient structure known as the cosmic web. These filaments stretch for hundreds of millions of light years, connecting clusters of galaxies like threads in a lacework of gravity. Between them lie enormous spaces, almost completely empty, vast regions where even starlight is a stranger. It is in this grand design that dark matter shows its greatest artistry, for it is the hidden architect that formed this web long before stars or planets existed. If you could drift through this structure, it would be like floating through an invisible forest. The branches would be made not of wood or leaf, but of gravity, silent and transparent, yet powerful enough to guide entire galaxies along their paths. Each glowing cluster you passed would sit like a bright dewdrop caught at the junction of invisible strands. The filaments themselves, though unseen, are built from dark matter, and through their gravity they pull normal matter, gas, dust, and light into place. Where the filaments cross, galaxies form, and where the crossings are dense, clusters bloom like bright flowers. The beauty of this arrangement lies in its quiet symmetry, a balance between emptiness and creation. Scientists first began to glimpse this cosmic web through computer simulations. By feeding the laws of physics into vast digital universes, they watched as dark matter spread through the early cosmos, clumping and stretching under its own gravity. What emerged was not chaos, but structure, an intricate network that looked almost organic, like the veins of a leaf or the filigree of frost on glass. When astronomers later observed the real universe through powerful telescopes, they found that reality matched the prediction. The galaxies were not isolated, but strung along filaments of unseen mass, tracing the same cosmic skeleton that the simulations had revealed. There is a quiet elegance in the thought that everything we can see, the stars, the galaxies, even the clusters of galaxies themselves, exists because of a pattern carved by something invisible. Dark matter did not just hold the universe together after it formed, it gave it shape before it ever began to shine. In the early universe, when everything was still a mist of particles and light, dark matter had already begun to gather, pulling gas into its hidden wells of gravity. These were the first seeds of the galaxies we see today, the first hints of structure in what might have seemed like endless chaos. If you were to travel through one of the cosmic voids, those immense empty spaces between the filaments, you might feel the quiet of true isolation. There would be no nearby stars, no planets, not even the faintest glimmer of a galaxy for millions of light years. Yet even there, the pull of dark matter would still be present, a soft tide moving through the darkness. And as you drifted toward one of the filaments, the faint glow of galaxies would begin to appear, like distant lanterns outlining the threads of a cosmic tapestry. To think that all of this, the structure of the universe itself, arose from something we cannot see or touch, is both humbling and deeply peaceful. It reminds us that even the grandest patterns begin with quiet foundations. The cosmic web is not a chaos of stars, but a harmony of invisible forces, arranged in ways our eyes can only barely trace. It is the universe's way of reminding us that the unseen is often the most essential, that emptiness can give rise to beauty, and that silence, stretched across billions of years, can become the very shape of everything. As you rest now, perhaps imagine yourself floating through that great web, each breath moving with the rhythm of the cosmos, each heartbeat echoing the pulse of the invisible threads that hold it all together. Long before galaxies spiraled into being, before stars were born or planets gathered their dust, the universe was a glowing sea of particles and light. Everything was new and restless, expanding and cooling, humming with energy. In that ancient glow, dark matter was already there, quiet and invisible, shaping what was yet to come. It did not shine or scatter light the way normal matter did, but it moved under the pull of gravity, gathering in gentle clumps that would one day become the seeds of galaxies. In its silence, dark matter was already writing the architecture of the universe. In those first moments after the Big Bang, matter and energy filled space almost evenly. There were no stars, no galaxies, only the faintest ripples of density, like soft waves in a calm ocean. Over time, those ripples grew under the influence of dark matter. Because it does not interact with light or radiation, Dark matter could begin to gather even when ordinary matter was still too hot to settle. It created invisible wells of gravity, small pockets where the pull became slightly stronger than elsewhere. These became the first cosmic nurseries, the quiet hollows into which gas would eventually fall and form the first stars. As the universe expanded and cooled, light began to travel freely for the first time. What was once an opaque glow became transparent space. The faint echo of that moment still lingers today as the cosmic microwave background, a soft radiation that fills the universe like a whisper of its beginning. Hidden within that afterglow is the fingerprint of dark matter, tiny variations in temperature that show where its invisible mass was gathering. These small irregularities were the earliest signs of structure, the first traces of what would become galaxies and clusters and the great cosmic web. It is humbling to imagine that the dark matter we speak of so casually is older than the first light. It was there before the stars, before the hydrogen clouds cooled enough to shine. It has been waiting patiently through every era of cosmic history, guiding ordinary matter as gently as a shepherd guides a wandering flock. The stars and galaxies that we see today are simply the visible decorations of a framework dark matter built long ago. Without it, there would be no patterns in the night sky, no stable orbits, no beauty to illuminate the dark. The universe we live in owes its shape to that early collaboration between light and shadow. When you look up and see the stars spread across the night, you are seeing the luminous half of a partnership that began nearly 14 billion years ago. The galaxies glimmer, but their roots are buried in the unseen gravity wells of dark matter. Every beam of light you see tonight has traveled along the contours carved by those ancient hands. And so, in the beginning, there was not chaos, but quiet preparation. The invisible gathered first, shaping the visible that would follow. It was dark matter that steadied the early universe, that whispered gravity's first instructions into the endless expansion. Even now, when we study the faint echoes of that time, we can still hear the rhythm of its guidance, slow and steady, patient as sleep. The universe did not burst into being all at once. It unfolded gently, like a flower opening in the dark. And somewhere, in that soft unfolding, dark matter was already there, holding space for everything that would one day shine. Some mysteries are loud, dazzling, impossible to ignore. Others live in silence, content to be felt rather than seen. The search for the dark matter particle belongs to the second kind. For decades, scientists have built machines, tunnels, and theories, all in pursuit of something that refuses to reveal itself. They have looked into the depths of space and beneath mountains of rock, listening for the faintest whisper from the invisible. Yet so far, all they have found is the beautiful, endless silence of the cosmos. It is as though dark matter has learned the art of hiding perfectly, leaving behind only its gravitational footprints for us to follow. Physicists once imagined that dark matter might be made of particles called WIMPs, short for weakly interacting massive particles. These hypothetical particles were thought to be heavy enough to shape galaxies, but so shy that they barely touched anything else. They would drift through stars, planets, even people, without a single collision most of the time. For years, enormous detectors were built to catch just one of these elusive interactions. In deep underground laboratories, tanks filled with liquid xenon or argon waited in perfect stillness, their sensors poised for a single glimmer that might betray the passage of a dark matter particle. But the detectors have remained quiet. The silence stretches on, patient and infinite, as though the universe is keeping a secret it is not ready to share. Some scientists now wonder if dark matter might not be WIMPs at all, but something stranger, perhaps axions or sterile neutrinos, or an entirely new form of particle that behaves in ways we have not yet imagined. Others suggest that dark matter might not even be a particle in the conventional sense, but a property of space itself, a whisper in the geometry of the universe. Every new idea opens another door, and behind each door is another layer of mystery. What makes this search so haunting is that we already know dark matter must exist. Its gravity shapes galaxies, bends light, and holds the universe together. The evidence of its presence is everywhere, but the thing itself remains hidden. It is like chasing the shadow of a sound, or trying to catch the reflection of something that refuses to face the light. There is a quiet poetry in that pursuit. It reminds us that the universe does not owe us its answers. Some truths are meant to be felt long before they are proven. Imagine standing in one of those underground laboratories late at night. The air is cool, and the hum of machinery fills the silence like a low heartbeat. Far above, the world sleeps, unaware of the tiny experiment unfolding deep below. You look at the detectors, still and silent, and you realize that even if nothing happens tonight, the waiting itself is part of the story. The search is not just for a particle, but for a deeper understanding of existence, a glimpse of the invisible architecture beneath everything we see. The particle that refuses to show itself is not taunting us. It is teaching patience. It is reminding us that discovery often comes not from demand, but from stillness, from the quiet act of watching and wondering. One day, perhaps, a faint signal will flicker in the dark, and we will know that we have finally brushed against the unseen. Until then, the search continues, not as a chase, but as a kind of meditation, a way of listening to the silence of the universe and realizing that even in its quietest corners, something extraordinary is waiting. When we imagine the universe, we often picture it as still, like a photograph frozen in time. Stars glowing quietly, galaxies turning slowly, planets tracing predictable paths around their suns. But in truth, the cosmos is not still at all. It moves, it flows, it breathes in patterns far too vast for us to see at once. Even dark matter, invisible and silent, participates in this motion. It forms halos that drift and merge, clumping and stretching across billions of years. Within those halos, galaxies perform their long, slow dance, bound together by gravity and guided by the unseen. It is a rhythm without sound, a waltz too slow for any music, yet it continues endlessly, shaping the sky above us. If you could watch the universe in fast motion, you would see galaxies moving through space like bright flecks of dust caught in a slow current. Sometimes they drift apart, and sometimes they come together, drawn by gravity into graceful collisions. When two galaxies meet, their stars rarely collide directly, but their dark matter halos embrace first. The invisible halos pass through each other, blending and merging, their gravity weaving a new structure where two once existed. The result is a newly shaped galaxy, different from what came before, its motion calm again after a long, slow meeting. In these interactions, dark matter acts as both anchor and partner. Its gravity guides the movement, deciding how the galaxies will twist and reshape. The process takes billions of years, longer than any star's lifetime, and yet it unfolds with remarkable gentleness. From our point of view, it is a silent performance, each motion too slow to see. But if we could watch the entire story sped up, the universe would appear as a vast ocean of light and shadow, with galaxies drifting like luminous plankton in the tide. The dance of dark matter is not chaotic. It follows the steady pulse of gravity, each movement balancing against the next. Galaxies orbit their centers like dancers circling a partner, their paths smooth and continuous. Even when they collide, the result is not destruction but transformation. The invisible halos that surround them absorb and redistribute energy, keeping the cosmic rhythm steady. It is this unseen balance that allows structure to exist, that lets the universe grow without ever tearing itself apart. Astronomers can trace these dances by mapping the distribution of galaxies across the sky. What they find are great flows of motion, clusters moving toward each other, filaments bending and shifting. When computer simulations recreate this on screen, it looks almost alive, a shimmering ballet of light woven through darkness. The galaxies follow the motion of their invisible partners, tracing arcs and spirals that stretch across space. What we see as stillness is really an endless waltz, unfolding over eons. There is something deeply comforting in that. The thought that even in silence and invisibility, there is rhythm, there is connection, there is movement that never ceases. The same gravity that holds galaxies in their embrace also holds us to the Earth, and the same unseen matter that shapes the cosmos drifts through us every moment. Everything is part of the same vast dance. If you listen closely enough, perhaps you can almost feel it, the slow turning of galaxies far away, the pull of unseen halos drawing them close, the patient harmony that holds the universe in motion. The dance of dark matter is a reminder that what is invisible is not lifeless. That motion continues even when no one is watching, and that every quiet orbit, every silent spin, is part of the same eternal choreography. As you rest now, picture that dance continuing above you, galaxies gliding softly through space, their invisible partners guiding them in perfect, unending rhythm. If the universe were a recipe, we might imagine it beginning in a bowl of time and energy, stirred gently with the forces of nature. Yet, when scientists measured its ingredients, they found something startling. The stars, planets, and gas that fill the night sky, all the things we can see and touch, make up only a tiny portion of the whole. Ordinary matter, the kind that shines, is just a small flavor in a cosmic mixture dominated by invisible elements. About a quarter of the universe is dark matter, and nearly 3/4 are something even stranger called dark energy. The universe we know, the one that feels familiar, is only a faint spice in an enormous dish we barely understand. Dark matter gives the universe its structure, while dark energy decides its fate. If dark matter is the glue that binds galaxies together, dark energy is the quiet breath that pushes them apart. These two unseen forces play opposite roles, yet they coexist perfectly. Without dark matter, galaxies would not have formed. Without dark energy, the universe might have collapsed long ago. Together, they create a balance that allows the cosmos to exist as it does, expanding, evolving, and drifting slowly toward an unknown horizon. Imagine standing in a kitchen with a pot simmering gently on the stove. You can smell the aroma, see the steam rise, feel the warmth, but you cannot see all the ingredients. Some dissolve completely into the broth, their presence known only by the flavor they leave behind. That is what dark matter and dark energy are like. They cannot be seen, but their influence fills everything. Galaxies spin the way they do because of dark matter's gravity. The space between those galaxies stretches wider each day because of dark energy's quiet insistence. The universe is constantly being stirred by their invisible motions. For many years, scientists assumed the expansion of the universe was slowing down. It seemed natural that gravity would pull everything inward over time. But when astronomers measured the movement of distant galaxies, they found that the opposite was happening. The universe was expanding faster and faster, as though some unseen force was gently pressing outward on all of space. This discovery changed everything. It revealed that the cosmos is not a closed system but a living, breathing entity, growing ever more spacious and quiet. Dark matter and dark energy may sound like opposites, but together they form a kind of harmony. One gathers, one releases. One binds, one frees. Their partnership gives rise to every shining thing we can see. The galaxies are like glowing flecks caught between their competing pulls, held in balance by a universe that knows exactly how to hold itself together. When you gaze up at the night sky, you are not just seeing stars scattered across darkness. You are looking at the luminous surface of something much deeper. Beneath the glow lies an invisible ocean of energy and gravity. still and patient, stretching in every direction. Everything we know, from the smallest atom to the largest galaxy, floats in that ocean, surrounded by the unseen ingredients of existence. It is humbling to think that we live in a universe where most of reality is invisible, yet it works in such gentle precision. The dark ingredients do not clamor for attention or light. They simply keep everything steady, ensuring that the stars continue their slow dance and that time keeps its even pace. Perhaps that is the lesson dark matter and dark energy quietly offer, that not everything that matters must be visible, and that the most powerful forces are often the ones that move without needing to be seen. As you drift toward sleep, imagine yourself suspended in that cosmic mixture, surrounded by quiet balance, held together by the unseen harmony of the universe's secret ingredients. There is a certain irony in the fact that one of the most detailed maps of the universe is made not from what we can see, but from what we cannot. Scientists have spent decades creating maps of dark matter, tracing its outlines across space even though it gives off no light and cannot be observed directly. It is a little like trying to chart the wind by watching how the leaves move, or sketching the shape of a river by following the ripples on its surface. What they have built is a portrait of the invisible, a map of gravity's fingerprints spread across the vastness of the cosmos. To make such a map, astronomers rely on a quiet trick of nature known as gravitational lensing. When light from a distant galaxy travels toward us, it bends slightly as it passes through regions filled with dark matter. The bending is subtle, but with precise instruments and patient observation, scientists can measure it. Each distortion reveals a bit more about the shape and concentration of the unseen matter along that line of sight. By collecting millions of these measurements from across the sky, they can piece together an image of where dark matter lies. The result is not a photograph in the usual sense, but a kind of shadow painting, one that shows where the universe is heaviest and where it is lightest. These maps often reveal something that feels almost artistic. They show bright nodes where galaxies cluster, connected by long filaments that stretch across unimaginable distances. Between them are great empty regions where matter is scarce. Together, they form a pattern that looks almost like the neural network of a brain, or the intricate frost that gathers on a window pane in winter. The universe, it seems, is a web of connection, and dark matter is the thread that ties it all together. When we look at one of these maps, we are gazing into the scaffolding of creation. Every dot of light, every cluster of galaxies, every filament of matter traces the structure that dark matter built. It is humbling to realize that the glowing parts of the cosmos, stars, nebulae, planets, and all the rest, are only the surface decorations of a deeper and more enduring framework. The invisible shapes the visible, quietly guiding it into place. The process of making these maps is painstaking. It requires years of observation and the cooperation of telescopes scattered across the world and in orbit. Scientists must remove the noise of ordinary starlight, filter out the distractions of atmosphere and distance, and read the faint distortions that dark matter leaves behind. It is as though they are tuning an instrument to hear a note that lies beneath all the others. When that note is finally clear, it reveals a pattern of gravity that stretches from one end of the observable universe to the other. There is something profoundly peaceful about this pursuit. To map the unseen is to acknowledge that not all knowledge comes from sight. It is to trust that the world holds more than we can perceive directly, and that patient observation can uncover truths that hide beneath the surface. The scientists who make these maps are, in their own quiet way, explorers of a realm without light. They are like cartographers of a dream, tracing the outlines of a landscape that exists in the language of gravity instead of color. When you imagine their work, think of them not as hunters of mystery, but as listeners to the universe's faintest whispers. Each measurement, each distortion of light, is another small clue in the grand pattern, Slowly, carefully, they draw the shape of the cosmos, one invisible curve at a time. And when they are done, what remains is a portrait of stillness and connection, a universe that reveals itself not through brightness, but through the soft weight of what holds it all together. In the year 2018, astronomers made a discovery so unexpected that for a moment, it seemed to shake the foundations of everything we thought we knew about the cosmos. They had found a small, faint galaxy that appeared to be missing nearly all of its dark matter. It was as though someone had discovered a bird that could fly without wings, or an ocean wave that rolled without water. This strange little galaxy, known as NGC 1052 DF2, seemed to glide through space without the invisible mass that holds every other galaxy together. Its stars moved exactly as the visible matter predicted, with none of the extra gravity that dark matter usually provides. For scientists, it was both thrilling and bewildering. For decades, dark matter had been the silent constant in the cosmic story. Every galaxy, every cluster, every grand spiral of light relied on it for its balance and shape. Without dark matter, galaxies should fly apart. Yet here was one that seemed to be doing perfectly fine, existing quietly in defiance of the rules. It was small and delicate, more like a wisp of starlight than a proper galaxy, and yet it carried the weight of an enormous question. To understand why this was so astonishing, it helps to remember how deeply dark matter is woven into our understanding of the universe. The motions of stars within galaxies, the clustering of galaxies into great webs, the very formation of cosmic structure all depend on its presence. Without it, the visible universe should be scattered and unstable. So, when astronomers discovered this ghostly galaxy floating along without it, they could hardly believe their instruments. They checked again and again, measuring the speeds of the stars, calculating the mass, comparing the glow of its light to the pull of its gravity. The numbers all said the same thing. There was no sign of dark matter. Some wondered if this galaxy had somehow lost its dark matter long ago, perhaps torn away during an encounter with a neighboring giant galaxy. Others speculated that it might be a rare kind of formation, born in an unusual region of space where the invisible matter never gathered. Whatever the explanation, it suggested that dark matter might not be as uniform as we had assumed. Perhaps there are places in the universe where it clumps more thickly, and others where it thins out entirely, leaving only starlight behind. There is something oddly beautiful about that possibility. It means the universe has room for exceptions, for quiet anomalies that remind us not everything must follow the same pattern. This little galaxy, drifting gently through the blackness, may be one of a kind. Its stars gleam faintly, untethered from the invisible web that binds most galaxies. It glides in silence, like a candle flame floating in still air. Even in its strangeness, it tells us something comforting. If there can be galaxies without dark matter, then the universe is even more imaginative than we thought. It is capable of variety, of subtlety, of creating systems that break their own rules and still remain whole. The cosmos, in its quiet complexity, continues to surprise us. When you look at the night sky, you are seeing countless galaxies, each held together by unseen forces. Somewhere among them drifts this rare one, moving softly through space, its stars alone carrying the story of its creation. It reminds us that even in the great patterns of the universe, there is space for mystery, for oddities that refuse to conform, for beauty that glows from the edges of understanding. And perhaps that is the lesson of NGC 1052 DF2, that even the absence of the invisible can still be a kind of wonder. Everywhere astronomers look, they find traces of something that does not shine. It leaves no color, no spark, no visible outline, and yet its presence is written into the behavior of everything around it. Dark matter, elusive and invisible, leaves behind what might be called its fingerprints. They appear in the way galaxies move, in the way light bends, in the way the universe itself clumps and stretches across unimaginable distances. It is like finding footprints in the snow when no one is in sight, or hearing a song echoing across a canyon when the singer has long since vanished. One of the most striking places where these fingerprints appear is in the rotation of galaxies. When scientists measure how fast stars orbit around their galactic centers, the outer stars move far faster than the visible mass should allow. It is as if something massive and unseen is pulling them along, a hidden hand steadying the spin. These invisible halos of dark matter extend far beyond the luminous edges of galaxies, shaping their curves and keeping them whole. Without them, the stars would scatter like leaves in the wind. We also see dark matter's touch in the way galaxies gather together. Instead of floating evenly through the universe, they cluster into great structures, bound by gravity, that goes beyond what visible matter can provide. Between these clusters stretch long filaments of dark matter, forming a web so vast that light itself bends as it passes through. This bending, called gravitational lensing, is another one of dark matter's quiet signatures. The light from distant galaxies arrives to us slightly curved, as if the universe itself has passed through an invisible lens. The distortion is small, but when observed across billions of light years, it forms a pattern that can only be explained by dark matter's weight. Even the faint afterglow of the Big Bang carries traces of this hidden substance. The cosmic microwave background is a relic of the universe's earliest light, and in its tiny temperature fluctuations, scientists can see the influence of dark matter. Those variations reveal how it shaped the first clouds of gas, how it pulled ordinary matter into the structures that would one day become stars and galaxies. It is a map of the invisible written across the oldest light we can observe. Each of these clues adds to a larger picture, but none of them reveals dark matter directly. Instead, it continues to whisper its presence through effects and echoes, never stepping into the light. This indirectness gives it an almost mythical quality. It exists not as something to be seen, but as something to be inferred, like the wind that moves through the grass or the gravity that keeps your feet on the ground. We know it is there because the universe behaves as if it could not exist without it. Perhaps there is something deeply human in the way we search for these unseen fingerprints. We, too, live surrounded by invisible forces, the pull of time, the weight of memory, the quiet influence of things that cannot be measured. Just as light bends to the gravity of dark matter, our lives curve around unseen truths. The cosmos reflects that same mystery, an endless interplay between what is visible and what is hidden. As you think of this now, picture the universe as a vast expanse of still snow, stretching forever under starlight. Across its surface are faint impressions, too delicate to disturb, showing where something heavy once moved. Those impressions are the fingerprints of dark matter, the quiet proof that the unseen has shaped everything. You may never see the hand that made them, but you can trace its motion in every galaxy, every shimmer of light, every quiet breath of the cosmos itself. Deep beneath the surface of the earth, far from the noise and the movement of everyday life, there are chambers carved into mountains and buried beneath ancient rock. Inside these quiet spaces, scientists wait with extraordinary patience for something almost impossibly small. They are listening for a whisper from the universe, a faint sign that a particle of dark matter has brushed against the world we know. The air is cool, still, and heavy with silence. These laboratories exist in darkness, not because they seek to hide, but because light itself would only get in the way of the delicate search for what cannot be seen. The detectors that fill these underground halls are like giant crystal hearts. Some are vast tanks of liquid xenon or argon, clear and still, guarded by sensors sensitive enough to capture the faintest flash of light. Others use crystals cooled to near absolute zero, so cold that a passing dark matter particle could leave a trace of heat behind. These instruments do not look for light because dark matter does not produce it. Instead, they wait for the most subtle of touches, a tiny interaction, a collision so gentle it might happen once in an entire year, or perhaps not at all. Dark matter is thought to pass through everything around us, even through our own bodies, without ever leaving a mark. Trillions of particles drift through the Earth every second, but they interact so rarely that the detectors must be shielded from every other form of interference. That is why they are built deep underground, protected from cosmic rays, radiation, and even the faint disturbances of the surface world. The scientists who work there spend years refining their instruments, checking every signal, learning to tell the difference between what belongs to the Earth and what might belong to the cosmos. Every so often, there is excitement, a strange pulse of light, a flicker of energy, something that seems to appear from nowhere. It is studied, tested, and retested, but more often than not, it fades back into the ordinary noise of the world. Still, the scientists continue to watch, because one day, perhaps, that faint signal will not vanish. It will remain, quiet but undeniable, and in that moment we will know that a particle of dark matter has finally revealed itself. The search is slow, but there is beauty in that slowness. It mirrors the pace of the universe itself, which changes not in seconds or years, but in ages. The scientists waiting in those dark laboratories are participating in a cosmic patience, one that stretches across generations. Their work is a meditation on stillness and attention, a reminder that discovery often comes to those who listen more than to those who chase. When you think of them there, sitting in the quiet glow of their instruments, imagine the serenity of their surroundings. The drip of condensed air, the hum of the cooling systems, the soft rhythm of breath under layers of stone. Above them, the world continues storms, laughter, footsteps, waves, while below, time moves differently. The earth shields them like a parent keeping watch over a sleeping child, and in that peaceful stillness, they listen for the faintest knock from the unseen. Perhaps no sound will come tonight, perhaps not for many years, but the act of waiting has its own grace. It is as though humanity has lit a small candle in the dark and simply agreed to keep it burning, no matter how long it takes for the light to reflect back. The laboratories remain silent, but within that silence lies the promise of revelation. One day, perhaps, a single flicker in the depths will tell us that something invisible has finally reached out and touched us. Until then, the scientists will continue their quiet vigil beneath the mountain, patient and steadfast, listening to the soft breathing of the universe as it passes all around them. Even now, as you listen, the invisible passes through you. It does not stop, it does not pause, and it does not disturb a single atom in your body. Every second, billions of particles of dark matter drift through the earth, through oceans and cities, through mountains and hearts, moving silently and unseen. You have lived every moment of your life immersed in it, surrounded by it, carried within its quiet tide. You have never felt its touch, but it has always been there, wrapping the planet in an unseen river that flows endlessly through space. To imagine it is to try and picture the intangible. Dark matter does not collide with ordinary matter, nor does it absorb or emit light. It slips through the densest materials as easily as sunlight moves through air. The planet does not block it, and the walls around you do not stop it. Every second, a steady wind of these invisible particles passes through the entire Earth and continues on its way, unchanged and unbothered. It is a haunting thought, and yet there is a strange comfort in it. The unseen is not hostile, it is simply indifferent, a quiet companion woven into the structure of everything. Astronomers have calculated that our galaxy drifts through a vast cloud of dark matter. As the Milky Way moves, It carries the solar system through regions thick and thin with this invisible substance, like a boat gliding through gentle currents. Earth, in its yearly orbit around the Sun, moves through the galaxy's dark matter halo at speeds of hundreds of kilometers per second. To us, that motion creates a steady breeze of particles flowing past and through everything we know. Some scientists even wonder whether this flow subtly changes over the seasons, as our planet's orbit alters its direction through the invisible sea. You can think of it as an ocean that has always been here, an ocean that requires no waves or light. If you could see it, you would find that every star, every galaxy, and every planet is suspended within it, like dust motes floating in water. We live within the body of this cosmic ocean, shaped by its gravity, yet never aware of its movement. It touches everything without touching at all, a paradox so serene that it almost feels like a dream. Some of the detectors buried deep underground are designed to listen for the briefest moment when one of these particles might interact with ordinary matter. Perhaps one day, a dark matter particle will strike a nucleus in a detector crystal, releasing a faint pulse of light that tells us the invisible has finally brushed against the tangible. Until that day, we must imagine it through the way galaxies move, the way space bends, the way we ourselves drift within it. There is a quiet beauty in realizing that we are part of this invisible current. You are, right now, in constant conversation with the universe, even if that conversation happens in silence. The dark matter passing through you has traveled from the edges of the galaxy, perhaps from beyond, unbothered by time or distance. It flows through everything, unchanged, carrying with it the memory of the cosmos. As you breathe in, picture those particles passing through your lungs, through your heart, through the air around you. They do not collide or slow, but they are there, countless and constant, like the softest wind the universe has ever made. The stars you see tonight are held in place by that same invisible tide. The galaxies themselves drift within it, their light wrapped in its quiet pull. In that way, you are never separate from the cosmos. The unseen ocean that cradles galaxies also moves through you. It is peaceful, eternal, and kind. A reminder that even in stillness, the universe continues to move through every part of who you are. There are artists whose brushes never touch the canvas, whose work is revealed only through its influence. Dark matter could be thought of as one of these artists, shaping the universe not with color or light, but with gravity alone. It paints in silence, using the weight of its presence to draw galaxies into being. Every spiral, every cluster, every glowing thread in the cosmic web owes its form to the gentle pull of something that does not shine. The visible universe is the finished artwork, but dark matter is the hand that shaped it. To see its art, astronomers study the way galaxies arrange themselves. When they map their distribution across the sky, they find patterns too deliberate to be random. The galaxies sit along filaments, stretched across the vastness of space like strokes of invisible paint. At the intersections of these filaments, galaxy clusters gather, forming bright knots of light. Between them lie the great voids, empty spaces where the brush never touched. All of this, the balance of fullness and emptiness, the texture of the universe itself, was created by the gravitational influence of dark matter. It is almost poetic that the greatest artist in the cosmos is one we cannot see. Dark matter does not emit light, it does not reflect or absorb it, and yet it determines how light itself travels. When we look at the soft arcs and distortions of distant galaxies, we are seeing how dark matter bends light around it, reshaping what we see. Each bend, each distortion, is like a faint signature left by the artist's hand, proof that something vast and unseen has moved across the canvas. The galaxies we know are like lanterns hanging along the brushstrokes of dark matter. Their light marks the places where the invisible gravity is strongest, where matter has gathered and settled. Without that invisible framework, the galaxies would never have formed. The early universe, filled with hot, uniform gas, might have expanded forever without ever condensing into the stars and planets we know. It was dark matter that provided the scaffolding, the quiet structure that guided ordinary matter into place. Every star owes its birth to this silent guidance. If you imagine the cosmos as a great fresco stretching across time, dark matter would be the plaster beneath the paint, the hidden layer that gives form and texture to everything above it. Without it, the image would have no depth, no cohesion. With it, the artwork gains its structure, allowing light to play across its surface in ways that reveal endless detail. Scientists sometimes speak of dark matter as the scaffolding of the universe, but perhaps it is better to think of it as a kind of composer. It writes in gravitational harmonies, setting the rhythm by which galaxies move and cluster. The melody we hear is light itself, resonating through the patterns dark matter has arranged. The two are inseparable, the unseen and the visible working together to create something vast and profoundly beautiful. When you look at the night sky, every point of light is part of this composition. Each star is a note, each galaxy a phrase, carried along by the silent rhythm of the unseen. The universe you see is only half the story, the illuminated surface of a masterpiece painted in both light and gravity. As you rest now, imagine the great cosmic artist at work. Picture gravity flowing like ink through the dark, gathering the galaxies into shape, sketching arcs and spirals across the deep silence of space. The universe, in all its beauty, is still being created in this way. It is a painting that never ends, a symphony that never stops. And even though the artist remains invisible, its work surrounds us completely, quiet and eternal, written into the very pattern of existence. When two galaxies meet, it is not the violent crash one might imagine. From a distance, their approach looks slow and almost graceful, like two enormous ships drifting toward each other across a dark ocean. Their stars rarely collide, for the spaces between them are vast. What touches first, what reaches out across that great gulf, is not light, but gravity. And the first to meet, long before the stars themselves intertwine, are their dark matter halos. These invisible envelopes of mass stretch far beyond the edges of the galaxies, so that long before the visible parts merge, their unseen halos are already touching, already beginning their quiet conversation. When those halos overlap, they begin to blend in a slow, patient dance. Gravity softens their boundaries, weaving them together like threads of silk. The stars and gas within the galaxies respond to this pull, shifting gradually toward a new balance. Over millions of years, the galaxies draw closer, their shapes stretching and twisting, their spiral arms curling into long streams of light. Some of the stars are pulled away entirely, forming trails that glow faintly in the darkness, like cosmic brushstrokes left behind. These are the marks of the invisible signs of the quiet work of dark matter, holding and guiding everything in its gentle, persistent grip. If you could watch this process unfold over time, sped up from billions of years to mere moments, it would look like a dance of light across the dark canvas of the universe. The halos merge first, then the stars follow, swirling around each other before settling into a new shape. The result might be an elliptical galaxy, soft and rounded, where once there were two separate spirals. The transformation is both inevitable and serene, as though the galaxies were always meant to find one another, drawn together by the silent hand of gravity. Astronomers studying these mergers often use simulations to understand the role dark matter plays. They see that without it, galaxies would pass one another too quickly, scattering apart instead of combining. Dark matter's gravity provides the patience necessary for union. It slows their motions, absorbs their energy, and allows the galaxies to settle together instead of tearing each other apart. Every glowing cluster of stars, every smooth arc of light we see through telescopes, is shaped by this unseen choreography. Even in these immense collisions, there is no chaos. There is rhythm. There is continuity. The invisible halos fold together gently, like two clouds blending into one, and the galaxies that emerge are often more stable than before. In the grand time scale of the cosmos, this process happens again and again, the universe reshaping itself with each encounter. The stars that once belonged to different galaxies end up orbiting together, carried within the merged halo of dark matter that now holds them all. There is something deeply peaceful in knowing that even destruction, on a cosmic scale, gives birth to beauty. The collisions that might seem violent are really acts of creation, guided by gravity's steady hand. Dark matter ensures that nothing is truly lost, only transformed. When two galaxies meet, their dark halos embrace first, their stars follow, and a new form takes shape, luminous and whole. As you drift now into quiet thought, picture those galaxies slowly merging, their light blending into a soft glow that spreads across space. Imagine the invisible halos surrounding them, overlapping like two breaths meeting in the cold. In that silent union, the universe reminds us that everything moves toward balance in its own time. The stars continue their orbits, the light continues to shine, and the dark matter continues to hold it all in a calm, eternal embrace. Dark matter has often been called cold, and while that term may sound poetic, it describes something very real about its nature. The word does not mean that it has a low temperature, though it might. It means that the particles which make up dark matter move slowly compared to the speed of light. They drift rather than race, glide rather than burn. Because they move so calmly through the universe, they can settle into structures that shape everything we see. They are the architects of galaxies, the sculptors of the cosmos, building not with light but with gravity. When scientists simulate the early universe, they begin with a nearly uniform sea of matter and energy. As time passes, small differences in density grow, pulled together by gravity. The cold nature of dark matter allows it to clump efficiently, creating the first scaffolds upon which ordinary matter can gather. Gas flows into these invisible wells, cools, and condenses into stars. Over billions of years, these quiet concentrations of dark matter have shaped the grand spirals and luminous clusters that fill the night sky. It is through stillness, not speed, that dark matter brings structure to the universe. The idea of something cold shaping something as vibrant as a galaxy is strangely comforting. It suggests that creation does not always require heat or violence, that the slow and patient forces can build what the fast and fiery cannot. In the vast silence between galaxies, dark matter moves with a composure that keeps everything balanced. Even as galaxies collide, it flows through them like calm water, guiding their movements and ensuring that their light finds a new place to shine. If we could see dark matter directly, the universe might appear as a delicate sculpture made of invisible clay. The galaxies would be its ornaments, resting within the curves and hollows of the unseen. The cold nature of dark matter gives this sculpture its durability. Unlike particles of light that scatter and vanish, these slow-moving particles linger, building the foundations of cosmic form and holding them steady. Astronomers believe that without cold dark matter, galaxies would never have formed at all. If dark matter moved too quickly, it would not have been able to clump, and gravity would never have gained the foothold needed to shape the cosmos. The universe would be a thin, diffuse mist, a place without structure, without stars, without anything solid enough to reflect light. Instead, the calm, deliberate drift of dark matter allowed gravity to draw the universe together, piece by piece, until the stars began to burn. In that sense, dark matter is a sculptor that works in silence. its hands unseen, its medium intangible. It molds space and time themselves, not through sudden force, but through quiet persistence. It holds galaxies in their places, shapes the paths of clusters, and steadies the rhythm of the cosmos. Everything that shines owes its symmetry and coherence to this slow, patient shaping. There is something meditative about this thought. The universe, for all its violence and brilliance, rests upon a foundation of stillness. The cold nature of dark matter is not absence, but serenity. It reminds us that even on the grandest scales, creation begins not with chaos but with calm. As you rest, imagine that stillness spreading across space, a quiet hand smoothing the edges of the galaxies, keeping their spirals gentle and their orbits true. Imagine drifting among those invisible sculptures, feeling the gravity that holds the stars in place. In that endless quiet, you can almost hear the universe breathe. It is slow, it is cold, and it is peaceful. The galaxies turn, the stars shine, and the unseen sculptor continues its patient work, shaping the cosmos one gentle moment at a time. There is a soft light that fills the universe, a faint and ancient glow that comes from every direction at once. It is not the light of stars or galaxies, but the echo of their beginnings, the memory of the universe's first warmth. Scientists call it the cosmic microwave background, the afterglow of the Big Bang, and within its quiet shimmer lies the first evidence of dark matter's presence. This light is almost unimaginably faint, stretched thin by the expansion of space itself. Yet it carries a story written in ripples and patterns that have lasted for more than 13 billion years. When the universe was still very young, it was filled with a dense fog of particles and light so thick that nothing could travel far without being scattered. The cosmos was a glowing ocean of heat and energy, turbulent and bright. As it expanded and cooled, the particles began to drift apart, allowing light to move freely for the first time. That light is still moving through space, reaching us as the soft microwave radiation we can detect today. But it is not perfectly smooth. It carries tiny variations in temperature and density, imprints left behind by the tug of gravity from invisible structures that were already forming. Those structures were made of dark matter. In those early days, ordinary matter was restless, tossed about by radiation, but dark matter was calm. It did not interact with light or heat, so it began to clump together sooner, forming invisible pockets of gravity that drew in surrounding material. As the universe cooled, these small concentrations became the seeds of galaxies and clusters. The cosmic microwave background preserves this moment in time, showing us where dark matter first gathered and how its presence shaped the first patterns of matter and light. Astronomers study these faint ripples with extraordinary precision, mapping their distribution across the sky. From those patterns, they can tell how much dark matter existed in the early universe and how it guided the formation of everything that came after. It is like listening to the faint hum of a lullaby from the universe's infancy, one that tells us how the first structures were born. Each tiny variation, each fraction of a degree in temperature, is a whisper from the past, reminding us that the unseen has always been there, steady and patient, guiding the visible world into being. If you were to listen to this afterglow instead of see it, it would sound like a soft hiss, uniform and calm, filling every corner of the sky. That sound, that gentle background, is the oldest thing we can ever observe. It connects us directly to the beginning, to a time when there were no stars, no planets, no galaxies, only light, gravity, and the invisible architecture of dark matter beginning to shape the cosmos. It is remarkable to think that something so ancient and quiet still reaches us. The universe has stretched and changed in every way since that moment, but the light endures. It drifts through the same space that dark matter continues to shape, both still following the rhythm set at the beginning. When we observe the cosmic microwave background, we are not only seeing the universe as it once was, we are hearing the echo of dark matter's first gentle influence. As you drift into stillness, imagine that faint glow surrounding you, the soft hum of the universe's memory washing over the edges of time. You are bathed in the same light that has been traveling for billions of years, carrying within it the first fingerprints of the unseen. It is a reminder that even the faintest whisper can last forever, and that the quiet work of the invisible is what makes the stars shine. There's a certain dreamlike persistence to the way scientists search for dark matter. Year after year, they design new instruments, new experiments, and new ideas to find what has remained hidden for so long. Each effort begins with hope and ends, more often than not, in silence, and yet they never stop listening. The search continues because the mystery itself has become a kind of wonder, a question so vast and quiet that it invites patience rather than frustration. Somewhere in that silence, they believe, there must be an answer waiting to be heard. In deep underground laboratories, enormous detectors wait for a single whisper of interaction, a flash of light too faint for human eyes to see. In high-energy accelerators, physicists collide particles at near-light speeds, hoping that the debris might reveal traces of something invisible. In space, satellites drift through the darkness, scanning the sky for signals that cannot be explained by known sources. Every approach is different, but they are all guided by the same longing to glimpse the invisible matter that shapes the universe. Some researchers have begun to think beyond the traditional models. They wonder if dark matter might not be made of heavy particles at all, but of something more delicate, perhaps something that interacts with itself or with the quantum fields that ripple through the vacuum of space. Others suggest it might be an entirely new kind of particle, smaller and subtler than anything our current instruments can detect. A few even propose that we have misunderstood the laws of gravity themselves, that dark matter is not a particle but a sign that the universe's rules are more flexible than we imagined. Every new idea adds another layer to the dream of discovery. To search for dark matter is to practice a kind of cosmic patience, one that mirrors the slow pace of the universe itself. The scientists know they may never find a clear signal in their lifetimes, yet they continue, each experiment building upon the last, each failure bringing them closer to understanding. The search has become less about catching the unseen, and more about learning how to listen more carefully to the silence it leaves behind. When you imagine these researchers at work, you might picture them in dimly lit control rooms, surrounded by quiet hums of machinery, their faces illuminated by the pale glow of computer screens. They adjust instruments, review data, and wait. Outside, the earth turns slowly, the stars rise and fall, and through it all, the invisible rain of dark matter continues to flow through everything. It moves through the detectors, through the mountains above, through the air, through the very rooms where the scientists sit. They are bathed in what they seek, yet it remains beyond reach. There is a soft irony in that, and also a deep peace. The search for dark matter is a reminder that knowledge does not always come from catching or holding, but from understanding what cannot be grasped. The universe does not reveal its secrets all at once. It unfolds them gently, like petals opening in slow motion across centuries. One day, perhaps, the detectors will record a faint shimmer of truth, a quiet confirmation that the unseen has spoken. Until then, the scientists dream and wait. They design new instruments, build better sensors, and refine their questions, knowing that even if the answer never comes, the act of searching is itself a form of connection. To seek the invisible is to participate in the universe's own curiosity, to join in its patient rhythm. As you drift now toward rest, imagine that same patience surrounding you, the quiet hum of the cosmos, the long dream of discovery, and the gentle belief that somewhere in the silence, The universe is whispering back. There is a theory, soft and strange, that somewhere beyond the reach of light there might exist a mirror world. It would not be a reflection in the simple sense, not like a shadow on a wall or a face in the glass. Instead, it would be a universe made entirely of dark matter, following its own rules and its own rhythms, invisible to us but as real and intricate as our own. It would drift alongside the cosmos we know, perhaps even overlapping with it, unseen yet present, a twin woven through the same space but speaking a language we cannot yet understand. Scientists call this idea the mirror universe, and though it sounds like something pulled from a dream, it arises from real questions. If dark matter makes up most of the matter in the universe, could it not also form its own stars, its own galaxies, perhaps even its own worlds? We know that dark matter interacts through gravity, but what if it also has forces like our own, forces that hold it together, shaping it into structures beyond our sight? In that case, there could be entire galaxies made of dark matter, drifting just beyond our perception, each one a ghostly counterpart to the galaxies we can see. The thought of it is both haunting and beautiful. Imagine a universe filled with invisible stars that burn not with light but with something else entirely, their glow existing only in the quiet hum of gravity. Picture galaxies turning in silence, their arms made of unseen particles, their centers bright in a spectrum our eyes can never perceive. Perhaps, in some faint way, these galaxies overlap with our own, their dark matter halos brushing against ours like ripples in deep water. We might pass through them every moment without knowing, feeling only the faint tug of their gravity as they drift through the same space. Some physicists believe that this mirror universe could even contain its own form of chemistry and physics, parallel to ours but disconnected from it. It might be ruled by a different kind of light, one that does not interact with ours, and it might host its own version of life, existing in forms beyond imagination. If such beings existed, they too would look out at their night sky, wondering about invisible matter shaping their world, never realizing that the answer lies within the lightless reflection of our own. To think of it is to feel a deep humility. The visible universe, vast as it seems, might be only half of what exists. The rest could be hidden in plain sight, folded into the same space, whispering through gravity but otherwise unreachable. It is a gentle reminder that our understanding, for all its progress, still swims near the surface of something endless. As you imagine this, picture the night sky not as empty but as layered, filled with unseen constellations that mirror the ones we know. Somewhere beyond your vision, another Milky Way might be spinning, quiet and dark, its stars moving in slow rhythm with ours. Its presence would be soft, invisible, and eternal, just as ours must appear to it. Between the two, the boundary would not be distance, but light itself a veil separating the known from the unseeable. Perhaps one day, through new ideas or new senses, we will learn to glimpse that hidden half. Until then, the mirror universe remains a dream within the cosmos, an invisible twin carried within the same expanse that holds us. The next time you look into the dark sky, let your imagination drift into that possibility. Let yourself feel the gentle weight of something unseen watching back, silent and familiar, its galaxies turning softly in parallel with our own, two reflections moving together through the endless sea of time. When we look at the night sky, it is tempting to think of the universe as mostly empty. The spaces between the stars seem endless, and even the brightest galaxies appear small and fragile against the dark. But in truth, the darkness is not empty at all. It is filled with something vast and gentle, something that gives shape and weight to everything we see. Dark matter, invisible and unbroken, stretches through every corner of the cosmos, holding galaxies in their places, and guiding the light of stars across unimaginable distances. It is a quiet, infinite, neither hostile nor cold, but steady and calm, the soft architecture of all that exists. In many ways, dark matter is the universe's stillness. It does not shimmer or burn, and yet it hums with quiet purpose. It keeps the galaxies from flying apart, keeps the clusters from unraveling, and holds the cosmic web in its delicate balance. Without it, the beauty of the night sky would collapse into chaos. Every sunrise, every planet, every point of starlight owes its existence to this unseen harmony. The visible universe, the one that sparkles and spins, rests like a thin layer upon an invisible foundation, as though all of creation were floating on a calm, unseen sea. It is easy to forget that we are part of this stillness. We tend to think of ourselves as small, temporary, separate from the grand workings of the cosmos. But dark matter reminds us that even the most ordinary moment is connected to something infinite. The same gravity that keeps your feet on the ground is the same force that binds galaxies to their halos, and it is dark matter that shapes how that gravity spreads across space. The pull you feel, subtle and constant, is part of the same invisible embrace that holds the stars. Scientists often speak of dark matter as a puzzle, a challenge yet unsolved. But perhaps it is more than that. Perhaps it is also an expression of balance, a reminder that the universe is not built on what we can see alone. Its true structure is hidden, quiet, and enduring, much like the foundations of a home or the deep roots of an ancient tree. What we see is only the blossom, fragile and bright, while the unseen does the work of keeping everything alive. When we imagine infinity, we often picture a vast emptiness. But infinity is not absence, it is presence without boundary. Dark matter gives us a glimpse of that truth. It is the quiet continuation of everything, the soft breath beneath the stars. Even though we cannot see it, we feel its effects in every orbit, in every beam of light that bends gently across the heavens. As you let your mind drift now, imagine yourself surrounded by that invisible calm. Picture galaxies suspended in the dark, each one glowing softly within its halo of unseen matter. Between them lies not nothingness, but the quiet fullness of existence, spreading endlessly, holding everything together. The stars turn slowly, the universe expands, and through it all, dark matter remains, patient and unchanging. It does not need to be seen to be real. It simply is, infinite and tender, the gentle heartbeat of the cosmos. And somewhere within that endless stillness, so are you, floating quietly in the calm gravity of the unseen. So, as you drift off and let your mind wander, remember this: even in the darkness, there is structure. Even in the quiet, there is connection. The universe holds itself together with threads we can't see, but somehow feel. May your dreams tonight be filled with the same invisible peace that shapes the stars. Sleep well, curious dreamer, and may the soft gravity of rest pull you gently into the night.